Good morning, South by Southwest. Today, I'm super excited for this presentation because I was selected to present last year for the very first time at South by Southwest. And unfortunately, it was canceled at the last minute due to COVID 19, and it was taken virtual at a later point. But today, I get to present virtually so that anyone with an internet connection in the whole world can watch it. So the topic of my presentation is what, why, and how about responsible artificial intelligence systems. A little bit about myself. I'm Swati Young, Chief Technology Officer of Integrity Management Services, where we provide healthcare solutions to the United States government. I'm also a proud Women in AI ambassador for Washington, D.C., and a Forbes Technology Council member. A little bit about myself. The year was 2000, and I was sitting in a cubicle in India writing code and writing code, but was wondering where exactly is my software being used. So my curiosity took me to countries like Belgium, where I sat beside a procurement officer and saw exactly how she was entering the purchase orders and the purchase requisitions and how the software was being used. And then the journey took me to United States, of course, and since then I've held every possible position in the world of technology. I was a developer, I was a product manager, I also was a senior director for engineering, leading engineering teams. But most recently, I started getting involved in implementing and designing artificial intelligence and machine learning applications. I recently co authored the Ethical AI Framework for the US federal government. And since then, I've been researching as to the appropriate ways to evaluate ethics of AI. But first, let me share with you an amazing video that you're all familiar with. So, depending on whom you ask, it could either be that this video is like really creepy or really amazing. So, I wanted to find out more about how to build responsible AI systems. So, if you go back to some people and ask, what did you think of the robots that are dancing to the tune? They think it's very creepy. Why is that? Creepy because robots are starting to act like humans and the sci-fi movies are coming to life and you're frightened when robots are taking over. Don't be so. If you come to know that actually it took over 1 year for robotics engineers to teach the robots how to make those moves. So let's talk about responsible artificial intelligence systems. So a responsible artificial system is one in which the dialogue is less about technology and more about its objectives and its use case. But why the hell should you care about building a responsible artificial system? Here I present to you the gendershades.org, a website that was created by Joy Bolamwini. I don't want to get her name wrong, so I had to refer to my notes. And here she shows how the bias data shows a very higher rate of error when it identified genders from countries in Africa compared to countries in Europe. Joy also started the Algorithmic Justice League to bring the issues of bias in AI to the forefront. This is a news that we all heard in January 2021. Why are people leaving WhatsApp for Signal? So one of the quotes I heard is that Signal says they do not store any chat logs or any metadata of users. So users are very well educated these days as to their privacy concerns and where their data is going. And they make a decision with respect to data and what applications they want to use. Hence, a lot of WhatsApp users moved away from WhatsApp into Signal. And then there's always the question of who is liable when it comes to a legal court of law. Is it the person who is investing in building the AI systems? Is it the person who is writing the artificial intelligence algorithms? Is it the person who is testing and certifying that the outcome of the system is good? Or is it the person who is actually the distributor or licensor of the software application itself? Or in case of autonomous vehicles, is it the operator of the AI system? All these questions come to the forefront. And of course, we in the United States have to uphold the laws against discrimination. For example, the 1963 Equal Pay Act mentions that you cannot discriminate based on gender. And the Civil Rights Act of 1964 mentions you cannot discriminate based on race. There's also the Citizenship, Immigration Reform and Control Act, where you can't discriminate based on your citizenship status. And then there is laws against age discrimination and the very, very popular and famous American Disability Act. So we want to make sure all these laws are kept at the back of your mind when you're designing AI systems. So why exactly do you need responsible AI? We saw with the example of Signal and WhatsApp that better products are actually serving broader populations and benefiting the entire society, as well as it creates a social impact. Of course, we noticed that the legal and policy aspects have to be on top of mind when you're designing and building AI systems. And last but not the least, sometimes building responsible AI systems might give you a competitive advantage in the marketplace as more and more of the public is becoming aware of the impacts and the negative outcomes of an artificial intelligence algorithm. So, how can you build responsible AI systems? The first thing I want to lay out is that responsible AI is a complex process, as well as the artificial intelligence ecosystem is pretty hairy and complicated. There is data acquisition you have to think about. You have to think about what type of applications are you building. You also have to consider whether the data is real time, that is changing constantly. In case of a self-driving car, it is, of course, real-time data because the data is changing every millisecond. And then you build your models or algorithms and you train these models. And once the models perform, you start monitoring these models. And we already saw the legal implications. So we want to make sure there's compliance and governance of these systems, as well as measure the impact to your organizational goals. So in order to simplify the process, I came up with an acronym. It's called NODES, which stands for the needs, objectives, data, ethics evaluation, and social trust. And we will go over one by one what it exactly means and how you can use this process to do and build, design, develop, and build artificial intelligence systems that are responsible. The very first one I want to address is the needs. When it comes to responsible AI systems, once again, I want to emphasize the fact that it is not just a technology problem. It's a problem entire organization-wide, or if you take a government agency, it's agency-wide problem. So what are your organizational needs? Most organizations want to optimize in terms of cost. Some organizations are looking at creating AI systems to penetrate new markets. Some organizations might dedicate a year or so to prevent customer churn. And most organizations might also think about increasing revenue, especially if you're a commercial organization. Here are some examples that we use on a day-to-day basis that align to some of those organizational goals. Netflix, there is a statistic that says if a user does not select a movie or a show to watch on Netflix in 10 seconds, they might move away from this streaming platform. So Netflix, the way they use machine learning is to optimize what you see on the screen as soon as you enter. And depending on your history, it gives recommendations to enable more users to increase their viewing, thereby increasing their revenue. Amazon. Amazon provides what next to buy based on your previous purchase history and sometimes even based on your search history. This is again helping them increase their revenue. Uber uses machine learning for surge pricing when the demand is very high. This can both optimize costs as well as optimize operations. Of course, we all know about the voice-based systems, whether it's Siri, Alexa, Google Home, etc. These are new products created to bring in new streams of revenue. And a simple example I want to showcase is machine learning used to filter the spam. The second point I want to emphasize is the objectives. So we saw at the very broad organizational needs. Now we break it down at the user level or the department level. What are some of the objectives or use cases? This is an example by Bank of America, and most credit card companies or financial institutions can use machine learning to detect fraud. So if you take the case, if you do not use machine learning, whenever there is a fraudulent activity on your credit card, you can report to the bank and the bank reimburses you the money. So the bank is losing millions of dollars on reimbursing money to customers whose card might have been stolen and used for fraudulent transactions. Now enter machine learning, and based on millions of data that the machine learns from, it can detect a fraudulent transaction from a not fraudulent transaction with very high level of accuracy. So supposing you're traveling to Europe and you're using a credit card, it might think that it is a fraudulent activity and send you an alert. And if it was really a fraud, it is preventing the bank losing money in tens of millions of dollars. So that's an example of machine learning for fraud detection. The other example is predictive maintenance. Imagine there is a ship stranded in the ocean with a huge component that has failed or broken down. Then the ship has to travel to the nearest port to replace that component. Imagine the time lost in doing that. Now, if you use a machine learning algorithm and feed it all the historical maintenance records of the ship's important machinery, you can get a predictive algorithm with high level of accuracy. And the least you can do is carry the component on the ship when it is on at sea and prevent this round trip to the port to replace a part. It is an example of cost optimization. So there are many use cases when it comes to artificial intelligence, and 90% of the use cases that organizations are using involve machine learning or natural language processing. So think about the use cases of, is it predictive analytics? Is it natural language processing? Is it Internet of Things that uses sensors? Is it image analysis like cancer detection? Or is it speech analysis like we know about other voice systems that we use every day? Now let's talk a little bit about business processes, because I like to say that as a data scientist, I do not understand your business, neither your data. So in order to build responsible AI systems, it's important to understand the business processes of the user. So take the example of cancer detection by doing image analysis of CT scans that contain the tumor. So you need to actually spend time with the radiologist to understand what he or she is using as heuristics. The heuristics can be mostly unwritten rules about how they generally look at a CT scan and determine the presence of a tumor or not. Then there are written business rules that you can you can actually become aware of so that it can help you build responsible AI systems. The third and important aspect is data sources. Yes, so the CT scan records are being generated by the hospital, but is it one hospital data or is it nationwide data? Do we have international data? Where is the data coming from is a very important question. And like, again, I will emphasize that ethics is not an engineering problem. You need to have the stakeholders in the room that bring diverse perspectives as to what they're expecting the AI system to do in terms of outcomes. Also, think about constraints. Sometimes they might be constraints as, okay, the data scientist is writing the machine learning algorithm, but the CT scan images will not be shared with you because it contains HIPAA PII data. That might be a constraint, and you might have to resolve it as to how to anonymize the data. Another constraint can be in terms of some heuristics. Sometimes the heuristics are lost from person to person, and it takes some time to determine what the heuristics are, and you have to dig deep into finding those. And then last but not the least, what are the key outcomes you're expecting the machine learning or AI algorithm to do? Like I mentioned before, too often data scientists or people who are writing algorithm are heads down and not thinking actually of the outcomes. They're thinking more about optimizing the algorithm for accuracy, et cetera, et cetera. So again, going back to the example of if a radiologist can use a machine learning algorithm to determine if the tumor is carcinogenic or not, we want to make sure we think about that outcome when we are building responsible AI systems. The third one is the crux of any AI system, which is data. I'm sure most of you have seen this image that was floating on the internet about 4 years back, where a person was trying to upload a photograph for renewing the passport or doing traveling, and the photograph was rejected, saying the subject eyes appeared to be closed. It's a real clear example that they did not have enough ethnic and race data to learn from. So unless the data learns from different types of races, how could it identify that this is not because the subject's eyes are closed, but a person could have eyes like this? And then we heard news stories when Amazon scraped its AI recruitment tool. And when it comes to recruitment, especially in the context of learning from historical data, obviously the gender biases creep in because historically women have held less leadership positions than men. And if that is the data the machine learning algorithm is going to learn from, how do you determine that it's not biased against women? So when it comes to data bias, you need to think of 5 aspects of questions to ask in the whole data lifecycle. So first thing is data sources. Like I mentioned, does the data sources involve local data or national level data or international level data? Do the data sources represent enough ethnicity, enough gender into the mix so that your machine learning algorithm outcomes will not be biased or skewed? Then we can think of data collection. How is the data being collected? Is it through an API, which is like a hook into a software system? Sometimes APIs can have constraints and introduce errors into the mix. Then comes the data processing. When you talk about data, like take the case of the cancer image analysis. If you have millions of records of previous CT scan images of people with and without cancer, but with a tumor, we need to make sure that we are feeding the appropriate data, and we are collecting the appropriate data. For example, if you're trying to think about or solving a problem for the tumor in the brain, feeding it data and mixing the data with the full body where the tumor is located anywhere else in the body does not make sense. So how is the data being processed? Data analysis is actually 60% of the time spent by a data scientist. Basically, we need to understand what are the features that are important to building a responsible AI system. Going back to the example of cancer detection, is gender, race, income, is that level of features important when we are doing data analysis? Or depending on the outcomes you're trying to predict, is some other features like where do they live, are they smoking, do they have substance abuse, and things like that. The medical history can be of importance. But again, going back and connecting the dots to the heuristics, if a radiologist says those are of importance, then you have to analyze the data and make sure you have enough data to represent that fact. And finally, you evaluate the outcomes. Okay, it is saying that there is a possibility of tumor with 95% of accuracy. And this is where I emphasize, yes, the machine learning algorithm is providing a recommendation, but here is where the human is in the loop and they evaluate the outcomes of the system. Now, best practices for bias mitigation. The very first thing I always want to emphasize is we need to have a diverse team, not just in the engineering or the data science team, but overall, even in the stakeholder team. So you need to have your HR to talk about the impact to your teams or the impact to human resources. You need your legal representative to talk about compliance and governance. And sometimes you need a philosopher to talk about ethics. You might even need a neuroscientist. So you need to have people from diverse backgrounds as possible to determine and bias and ask the right questions, because as humans, we do have cognitive biases and it's only going to seep into the data. So we want to make sure we have the diverse team. And then outcomes and expectations is what is the result you're expecting out of the machine learning algorithm and how are you going to be used? How are you using that outcome is of question, because if it is used by a judge in a court of law to determine whether he or she has to give bail or not, that's a huge outcome and expectation. So think about those. Data provenance means where is the data originally coming from? So in the case of cancer detection, we know that if a patient comes in, complains of headaches, you take a CT scan of the brain and see if there's a tumor in the brain, things like that. So where is the data originating from? And sometimes you might go off after a publicly available data set and you want to make sure you find out the details. Did it come from all the states in the United States, or did it come from international patients or international hospitals and so on? And we already spoke about why it is important to build inclusive data sets, include race and gender and ethnicity and all kinds of informations, like Joy has pointed out in the gendershades.org. And then we have balanced data sets. Obviously, in case of fraud detection, when you talk about data, you might have more records that are indicative of non-fraudulent transactions compared to fraudulent. And data scientists can make sure that they balance the data sets before they build the algorithms. Modeling and monitoring outputs, again, it's more a technology problem. As you're deploying AI systems to production, you continuously monitor how the outputs change over a period of time as data keeps changing. And fourth one is ethical evaluation of AI systems. And this subject is close to my heart, as I was a huge proponent and participant in ethical evaluation of AI systems framework for the US government. And in this case, I again want to showcase an interesting example. When Apple first released its credit card, Steve Wozniak, the co-founder of Apple, actually tweeted saying his wife was rejected when she applied for the card, and he and his wife actually shared bank accounts and credit cards and assets. So he was pretty surprised when it did that. And here we also see another tweet by the Ruby of Rails founder here, who also is saying that it is biased against women. So ethical evaluation, yes, this is a big example of it. A few years back, Tay was one of the chatbots that was released on Twitter, and it took less than 24 hours for Tate to go rogue, and it started, spewing really negative tweets, and it had to be taken down within 24 hours. Next one is a question often asked as the trolley problem. Who is liable for an autonomous car accident? And how do you determine the ethics behind the car making a determination whether to save the pedestrian or whether to save the driver? So when it comes to ethical AI principles, the factors that you can evaluate are bias, like we have already seen with respect to data, but we can also evaluate bias with respect to outcomes. There's also the question of fairness and transparency, and all these put together, it builds trust in accepting these AI systems to be utilized in whatever use case the organization determines, as well as building trust with the public and society as well, because it's very important the systems we use, especially when it comes to AI, change the way we think, work, and live. So it's important to build the trust as an organization as well as a society. This is an interesting thing. Like I said before, ethics is not just an engineering problem. We are looking at building solutions that are ethically justifiable, but also legally defensible in a court of law. And finally, technical feasibility is of importance. And so the question of fairness is of utmost importance when it comes to evaluating ethics of an AI system. And there are several frameworks that you can use to evaluate fairness. Microsoft has one. They have published the AI principles for fairness. They also have a tool called FairLearn. IBM 360 also helps in evaluating the ethics of an AI system. And the image on this right is the ethical evaluation of AI system and framework that I was personally involved in co-authoring for the US federal government. And there are other tools that have been provided. Most of them are open source, like Google What If tools, H2O bias detection. I already mentioned Microsoft FairLearn, IBM OpenScale responsible metadata and fact sheets that you can use to evaluate the ethics of the AI system or the outcomes of the system. This is an interesting example published by ProPublica about how the risk factor has been determined by an algorithm. The person on the left committed a higher crime and was assigned a low risk of 3, whereas the person on the right, she only stole a bicycle and she was provided a high risk of 8, which drives their bail and also their whether they have to go to jail or not. And in this use case, it was not very transparent how the algorithm or the software recommended this high risk score of 8 versus 3. Because if you read it as a person, it does not make sense and does not appear to be justifiable. So when it comes to evaluating ethical outcomes of an AI system, it's important to see what is the transparency. How can the algorithm determine this risk score based on what? If the AI system can be transparent, that goes a long way into building trust as well as ethically justifiable systems. So when it comes to transparency, what are some tools that you can use to evaluate? The explainable AI models is something that has been under research and started coming mainstream in the last couple of years. Glass box models are traditional regression models and machine learning algorithms that you can use, like a decision tree that will show you what is the tree that has taken to the next step of the decision-making process. Black box models are mostly applicable to deep learning, CNN, and so on. They're either interpretable models like LIME or more explainability through SHAP. And these are some things you can ask your data scientists about. The last but not the least is building social trust. So you do have AI applications for social good like climate change and humanitarian actions, as well as cultural heritage and accessibility. This is an example that Microsoft is building, the Freshwater Trust, where it takes images of satellite about the groundwater and builds a machine learning algorithm that optimizes between conserving the environment and making sure that the fresh water is available for residents. And the next aspect of trust is data privacy. We all came to know how Facebook's integration with Cambridge Analytica and the data that was shared violated a lot of privacy issues. And we have to consider the PII and HIPAA when we think about privacy of individuals as well as healthcare data of individuals, because we use vast quantities of data from machine learnings to learn from. It's important to anonymize the data as much as possible so that you are not backtracking who the person is, and making sure you're checking your boxes when it comes to PII and HIPAA. So in conclusion, some of the key takeaways are: what are your needs of your organization or your government agency? What are the objectives and use cases that you can think about for using AI systems? And maybe sometimes you don't need an AI system, you need to debate and discuss before you make the decision. And when it comes to data, addressing bias is an important part of data. You need to audit for the fairness and transparency in the context of building responsible AI system. And building trustworthy systems starts with social trust, which you can do so by ensuring the privacy of the data. That's all for today. Thank you so much. Please connect with me on LinkedIn or Twitter at Swati Young, and subscribe to my YouTube channel, The AI ML Show. Hope you all have fun watching this session as well as the remaining South by Southwest sessions. Thank you so much. Bye.